Good day. So this video is a continuation of our previous video on the basics of R programming. So I'm just going to cover some things that I wasn't able to cover in that video, particularly the loops, how to create loops, especially if you have several regression specifications that you want to run. And that's normal in typical econometric analysis. If you visit research papers, you would see several models being estimated or presented all at once. Right, and of course you don't want to run the same same line of code over and over again. So I will show you some shortcut on how to run that without how to estimate that with ease using R. And I'm also going to show you how to generate new variables, uh, conditional variables, variables with certain statistical, derived from certain statistical computation, and how to add them in your existing data frame. So two topics for this short video. So I'm going to use the same code that we worked on in the previous video. And let me just run this, since this is a new instance of R. Let me just run my codes, or let me just invoke the libraries that we need to start working. All right, and let me just set the work directory df. All right, so our working data set is the wage one data from Woldridge. Of course, you can do this. You can also do this in Stata, right? But it turns out after a few times of tinkering with the software, it turns out that it's pretty much straightforward in R as well, right? Generating new variables, generating special variables, and doing the loops, right? Or creating loops within your code. It's also pretty straightforward in R, right? And I'm pretty sure that some of the exercises for my students this term, the exercises that require you to use data can also be accomplished using R. Okay, so there's no issue with that. Okay, so let me just run this. Right now, our data frame is loaded. Right, maybe I can I'll skip a couple of lines here. Let's go straight to the loop scenario. Right, so in the last video, you're asked to generate, or you're asked to estimate several equations. Right, you're asked to estimate several equations. All right, so M1 to M5. Some studies would actually may require to run more than 5 equations, right? Just to see the robustness of your specification, right? That's typically done in econometric analysis, all right? Just to be sure that your variable of interest doesn't really change. The magnitude of your variable of interest doesn't really change with respect to different specifications. So that's a test for robust. Not really a test, but more like a check whether your estimates are robust or not. So let me set these objects, right? Right, so you have your 5 equations. So you have your 5 equations as objects already loaded in R, right? Earlier, we did the regression separately, but it turns out that we can do it. We can also do it through a loop, all right? So I'm going to show you 2 ways to run the loop command, right? How to run the loop command. The for loop, which is the base R functionality, right? The base R functionality, and the lapply, right? The lapply command. Some R experts recommend the use of lapply, the list apply, over for loops, right? But then again, the functionality is the same, right? And probably for more complex tasks, lapply is a more versatile package than the base for loop command of R. Right? But let's try that. Okay, so you have 2 ways, right? So I can run the for loop, all right? So let me just describe the code here. So we have a for loop function here, right? So that calls for I within the range of 1 to 5. So I here will invoke M1 to M5, right? It will invoke M1 to M5, right? So line 71, so now that we are in a for loop environment, so 69 to 74 is a for loop environment. I'll be assigning an object name for the regression result. So the object name for the regression result would be R underscore I, where I represents the number 1 to 5, or the range from 1 to 5. So it's a two-step process, not as straightforward as your global macro in Stata, but it yields the same functionality, it yields the same output. You just have one additional step, and that is you need to pre-assign the object, right? You need to pre-assign the object name for your linear regression result. So that is what is being done in line 71, all right? We assign we assign the object name, right, which is called res, and we assign this is basically a list of object names, right? We're assigning a list of object names for our regression results. So base zero function here is more like a concatenate function, right? Wherein we're concatenating R underscore with the respective number I, right? As the for loop runs from 1 to 5. So you're basically assigning R underscore 1, R underscore 2, R underscore 3, 4, and so on. Right? Now the second line, 72, that's where the regression starts. All right. So we're assigning an object. 72 basically assigns the object name res, to this regression result, or basically the other way around. We're assigning the regression results LM, or assigning the regression results from LM to the respective object name in res, right? Which is R underscore I, where I represents the number, right? So the loop runs through, so basically the linear regression runs through this loop, right? So we're getting the object name, right? The get function ensures that the formula is intact. So when you invoke the particular object, it is retained as an object. Without this get function, it will result in an error, because it will, instead of yielding say M1, M2, M3, M4, M5, it will produce the object names enclosed in quotation marks, and R will not recognize that as a formula. It will recognize that as a string or text. So to avoid mistakenly recognizing or mistakenly calling the object names M1 to M5 as a string enclosed in quotation marks, you will need the function get, right? So LM, so notice here, so basically we are still getting M1 to M5, but we're just doing a shortcut, and we're letting R run across these models, right? So, and your data frame is still the same. Data is equal to DF. So let's try to run this. And of course, after running the regression, we now have the results stored in R1, R2, R3, R4, and R5. So R1 would be your eduk experience, and so on. R2 would be eduk experience and experience rate, and so on. Okay. Now we can view the respective regression results by typing summary. Let's type summary R1. Right? And those are the results, right? You have your eduk and experience, or actually, if you want, we have another shortcut for I in 1 to 5. So letting I run from 1 to 5. Let's try to look at the summary get. Let's try to use the get function. Paste 0. So basically, you're concatenating without spaces. R and I. Okay. Okay. I'm sorry, it didn't show up. Huh? Right, so unfortunately it didn't show up, but you can just type in the summary. Of course, you're gonna look at it one by one, right? You're gonna look at it one by one, so you may want, I might as well take the summary of each model separately. Now you can still write the same output, right, via outreg, right? So you have your output. Let's type the output. Well, let's set it as output 1, and you can still use the outreg result or outreg function. Right? Let's type the outreg function, but instead of using results 1, we're gonna type R1 to R5. So R1, R2, R3, R4, R5. Okay, so you have your output and you have your data frame, storing your regression, basically storing your regression output. So it's a really nifty looping command. Just gonna take it's just going to take you a while to really master, get the hang of writing the codes, especially if you're already familiar with another programming language. But of course, starting from scratch may be a little daunting, but it's gonna be easy. It's gonna be easy later on. So that's the first type of loop, right? The other one is the list apply or L apply, right? So there are several types of apply here. So you have your apply, you have your L apply, you have your S apply, you have your T apply. You can just check the help files, right? You can just check it out online, what the distinction among these type of apply functions, right? So the idea is still the same, right? The idea is still the same. So we're still going to loop the lm function. So this is your lm function in line 83. We're going to loop this lm function or this regression function across all values of I. So I runs from 1 to 5. So we need to preset what I is. Okay. So in line 79, we're going to preset the range of values from 1 to 5. All right. So let's run this. And so we now have a vector, basically we now have a vector of values from 1 to 5. And we're going to plug in the output. Let's name it output 2. We're going to store the regression output in the object output 2. All right. And we're going to apply it on a list that runs from 1 to 5. And we're going to run this function, right? And notice that the function is the same as in line 72, right? So same as in line 72, right? We're still going to invoke objects M1 to M5 here. So in line 83. So let's run this. And now we have a regression output stored in output 2. Now the difference of output 2 is that output 2 is not a data frame. It's not a data frame, and you will have to invoke each output. Let's try to open this. Output 2, sorry. Still need to invoke their respective object numbers. Or I'm not sure if we can write this as a column, but if you wanted to say get the result for say output 1, you would need to call out output 1. Output 2 rather, output 2, 1. Right? And those are your intercepts. All right. You can also maybe type summary output 2. Oops. Right, so it's already an object. So you can just type it as output 2. And you will get the coefficients. The other coefficients. Okay. So you can loop them, or you basically loop your regression commands in 2 ways. Although the first one probably is the base command is more straightforward because you can store the results right away and you can outreg the results, right? You can outreg the results. But lapply can also work, right? You can also use lapply. It's an option. Okay. So those are your looping commands. So we already discussed this, line 90, how to outreg the results. It's also in line 70. It's also in line 77. Now, just a quick, um, just a quick review. Just a quick review of how to create new variables. Something that we missed in the previous video. So there would definitely be times wherein you'll be asked to generate a new variable, right? Generate a new variable and include that in your data frame. Right? In Stata, you call that the generate command, or you can also use the replace command. So it's a tandem. You can use generate and replace, or you can use the egen command for a more specialized functionality. Okay. Now, in in R, we have what we call the mutate command. All right. So to run a mutate command, suppose you're asked to say generate a dummy variable, right? Dummy variable that's equal to 1 if wage exceeds 10, some arbitrary number 10 and 0 otherwise. Right. So to do so, let's invoke the data frame. We're doing this because we wanted to add that column in this data frame df. Right. So let's invoke the data frame, use the pipe function, right, and type mutate, right, and let's type the new variable name. So let's type wage dummy equals, right? And since this is a conditional variable that sort of an indicator function that's equal to 1 if another variable is equal to a certain value or not, right? So so let's type in if else, right? So if wage is, say, greater than or equal to 10, right, let's type in 1. Otherwise, it's 0. Right? So this if else command will set the condition where wage dummy will be equal to 1 or 0, much like your if command in Excel. And there goes your df function. So we can test that. We can test that by generating the summary stat for wage. So let's take the summary stats for wage. So group by df wage dummy. Okay, and let's summarize wage min wage max. This min max will tell us whether the generated variable is correct or not. Okay, let's run this. All right. So it turns out it's correct, right? So notice that the maximum value of 0 is at 9.85, which means that all of the observations whose wages are below 10 belong to category 0. And those wages whose wages, and the group whose wages are equal to 10 and higher belong or is captured by the second group, right? So that's your mutate function. Let's have another example. Suppose you're asked to get a group. Suppose you're asked to get the average wage, right? Say get the average wage across marital status or by marital status, right? So it means that you need to generate a variable that varies by marital status. So you have your average wage for the unmarried observations, and you have the average wage for the married observations. So let's try to do that. So we have your df. Let's call the data frame df. We have your pipe function, and let's call mutate. Right? And let's try wage marital. Right? Oh, sorry, we need the group, right? So we need to group it. So you have your group by df, and you have your married or your marital status dummy. Right? So you're telling R that you need to generate this mutate variable by group, right? So you're gonna group it by marital status. So you have your mean wage, right? And you have your new variable now, right? So you can actually view it. View F. We can try one variable. Wage marital. Okay, no. Maybe you can need to type it in a group C. Oh no. Okay. Let's just view it as it is. All right. So you have your wage marital, which now varies, right? Which now varies according to marital status. Right? So you have your marital status, married, 0 or 1, right? So you have the wage marital based from this data view. The wage for unmarried is 4.84. The wage for married is 6.57. Now we can check that. We can check the values. Right? So check by running the group by summary stats. Right? You have married. So that's correct, right? So for unmarried, the wage is 4.84. For the married observations, it's 6.57. And it's attached correctly to our data frame. Okay. So that concludes our short tutorial video on the basics and some little bit of advanced looping functionalities in R. For additional help, if you need more assistance in running or using R, there are a lot of videos, there are a lot of supplementary videos, tutorial videos out there, and you can also visit the forums, Stack Hub forums or GitHub, Stack Exchange forums and GitHub forums for additional help. Right? Just don't be overwhelmed because there's so many alternative solutions out there depending on your task. Right? So thank you so much for listening to this video, for watching this video.